Right, we're going to look at a simulation model now of the line. The different stations are represented using machines. Ankit, Jared, and Jackie and Neil are in our model as machines. And the planes are going to flow through this line and are going to be represented by brown balls. We're going to run this simulation for 3600 seconds. And the reason we do that is we really need to observe the line for a lot longer than the couple minutes that we saw in the video to establish if the behaviors that we anticipate really are going to manifest over a longer period of time. To convince you that the modeling is relatively faithful, let's take a look at the timing on Jared's workstation. He has a service that is going to be assumed to be exponentially distributed with a mean time of 22 seconds. The exponential distribution is a reasonable distribution model for human operator service. And consider Jackie's station, which we're expecting to be 28 seconds, again also modeled using an exponential distribution. So the model is stochastic, and Neil would be at the 14 seconds as you're anticipating. We're going to run this model slowly at first so you can observe the behavior. And I'm going to start it now. And we're going to zoom in on Ankit station and see what's going on. These models are actually three-dimensional, so we can see Ankit station here. And you can see the planes as represented by the brown balls flowing through the process. Okay, let's see what accumulations we have. Jared's already got some work building up in front of his station, and so is Jackie. We can increase the run speed just a little bit here and have the planes go through faster. And then the model allows us to observe what the utilizations are at the two workstations. You'll see Jared's got some backup as we anticipated. That's the work in process that we saw in the original video. And Jackie's workstation is currently 94-95% utilized. You notice that Jackie is not able to clear her buffer, and that indicates that in fact she is slower than Jared, and so she is the bottleneck workstation. We can get better indications of the actual activities of a workstation. This is a pie chart representing the idle and processing or the utilization percentages of Jackie's workstation, and as you can see they update in real time as the simulation unfolds. Alright, let's zoom out now, and you can see Jared's work is really building up. And what I want to do now is I'm going to really crank up the run speed so that we can finish the 3600 seconds. We now have done that, and we can observe what the throughput of the line is by going to Neil's station. Excuse me, let's take a look at this again. We click on his statistics, and we're able to see that the throughput of his station is 131. That means that 131 planes crossed his desk during the hour. So that would be our estimate of the throughput of the line. Now, this is close to what we estimated with our calculation of 128. And the difference would be simply due to the fact that we have some stochasticity involved in this simulation model via the assumption of the exponential processing time distributions at each workstation. That's our model.